with methods of separating mixtures, and then we try out some exercises. Right? Today, we will start a new chapter, that is different types of materials too. Now, in our daily lives, we use a lot of things, a variety of things. It can be utensils, boxes, tables, chairs, bicycles, mobile phones, books, pencils, shoes, slippers, TV, etc. Now, a lot of things that we use in our daily life are an important part of our lives. Okay? They help us to sustain. Okay, then but these things were not available in ancient times. Hello, Ibrahim. Good morning.
Hello, ma'am. Good morning. Sorry, I'm late.
It took thousands of years for humans to learn to make them. In this long journey, when humans learned to use the available materials around them, they invented many new substances as well. In this lesson, we will learn about different types of substances and their use. Okay. In ancient times, people didn't have a lot of resources. Okay. Nowadays, we have a resource, a gadget for everything. Okay. Be it for cutting vegetables, peeling vegetables, we have objects which help in that. Okay. Then we have objects to cook in. Okay. Then we have plates to eat in. Ancient times, people had only like knives were also invented later by them. They used to cut it with stone or sharp objects, and they used to cook the food directly in fire, and then they used to eat knives. Okay, so that was the ancient time. That's how it used to be in ancient time. Then slowly people discovered that things can be made. Okay, they started inventing. Okay, they started inventing. Then slowly they invented different kinds of things, and they invented it using different kinds of materials. Okay, and also they invented different kinds of materials also. Okay, then first up is minerals. Okay, now we use a variety of things to meet our needs, like utensils to prepare food, clothing to wear, home to live, furniture to sit and rest, and bicycles, fridge, mobile, TV, car, etc. for leisure and entertainment. All these things are made up of some material. Where do all this material comes from? Some material are found in the earth's rocks naturally as minerals, while others are made by human beings in factories and industrial units. How do we obtain all of this material with which our things are made up of? Some of them are obtained from the earth. Okay, in the earth's rocks that occur naturally, whereas some of them are made in factories or industries. Now, all of this happens due to our growing needs because human needs are never satisfied, right? Our needs keep on increasing and increasing. And according to the increase in our needs, the upgradation in technology takes place. Okay, according to our needs, of technology takes place. Then, as our needs increased, people were inspired for making items from different types of substances. Now, I just told you, hello Anna, good morning. I just explained that materials can be obtained naturally from Earth's rock, and materials can be made in the factories or industries. So the ones which can be directly obtained from naturally from the earth, okay, they are known as naturally occurring minerals. They are known as naturally occurring minerals. Why? Because they occur naturally. They are formed naturally without humans creating it. They are of two types. We have non-metals and metals. Okay. Now, there are total of 89 types of minerals that are found in India. How many? 89 types of minerals. Out of these, 11 are metallic and 52 are non-metallic. 4 are fuels and there are 22 other minerals. Okay?
Ma'am,
Yes, Abraham.
what is an example of a non-metallic ore?
What is an example of non-metallic? Non-metallic examples are Abraham mica. Okay, mica is you can say a type of stone. Then limestone is there. Then dolomite, gypsum, and asbestos. These are the stones or rocks you can say that are metallic in nature.
Ma'am,
Okay, they do not have the
ma'am,
properties. Yes,
and the 22 others?
and the 22 others, you look it up, Abraham. Okay, look it
Ma'am,
up. What?
ma'am,
Yes.
would it be diamond, uranium?
Okay. Check it out. Okay. Look it up and check it out. What are the 22 other types of minerals? Okay. Now, now we get metals from metallic mineral. They are also called ores. Okay. So here is the definition of ores: the minerals from which the metals can be extracted profitably and conveniently are known as ores. Okay, those minerals from which we can extract metals are called ores. Okay, look at this table. There are metals. Okay, and the metals are extracted from what ores that is mentioned, and in India where they are found that is mentioned. Okay, so we have iron metal that is obtained from the ores of hematite and magnetite.
Ma'am,
Magnetite, yes.
will these be asked in the test?
Will this be asked in the test, Abraham? I can ask, give an example of an ore, okay, and the metal obtained from it. So one or two you have to remember, okay, or define ore with an example. That can be asked. I will not ask this whole table, okay, not the whole table, but yes, one or two you have to remember. Okay, an example might come that give an example that you're able to write it. Okay, okay. Then there is copper metal that is obtained from pyrite ore and it is found in Rajasthan, Bihar, Madhya Pradesh, and Andhra Pradesh. Then there is aluminium metal that is obtained from bauxite ore, which is found in Madhya Pradesh, Orissa, Gujarat, Bihar, Andhra Pradesh, and Maharashtra. Then there is manganese metal obtained from pyrolusite ore, which is found in Karnataka, Madhya Pradesh, Orissa, Maharashtra, and Gujarat. Then gold, it exists in Free State. Okay, then it's found in Karnataka and Andhra Pradesh. Okay, then, then we have non-metallic ores and their location. Non-metallic ores cannot extract metals. Hope you know that. Okay, because only metallic ores we can extract metals. Non-metallic ores we cannot extract metal. They are in the form of stones and all. Okay, like mica, limestone, and all. Now let's see where they are found. Mica is a non-metallic ore found in Bihar, Odisha, Tamil Nadu, Rajasthan, Andhra Pradesh, and Gujarat. Limestone, which is found in Madhya Pradesh, Andhra Pradesh, Rajasthan, Gujarat, Karnataka, Bihar, Odisha, and Tamil Nadu. Then we have dolomite ore found in Madhya Pradesh, Gujarat, Karnataka, West Bengal, Maharashtra, Uttar Pradesh, and Odisha. Can I have your videos on, please? all of y'all. Then we have gypsum, which is found in Rajasthan, Jammu and Kashmir, UP, Tamil Nadu, and Gujarat. Then asbestos, that is found in Karnataka, Bihar, and Rajasthan. So now, right now, we studied about minerals, naturally occurring minerals that can be classified into two categories, metals and non-metals. Also, these metals are obtained from they are obtained from ores. Now, ores can also be classified into two categories, metallic ores and non-metallic ores. Okay, minerals basically. Minerals are classified into four categories: metallic, non-metallic, fuel minerals, and other minerals. Okay, then after that we have metals and non-metals. Okay, we are familiar with a number of materials which are made up of metals like iron, copper, and gold. We also use them in our daily lives. Similarly, we are familiar with many non-metals and their uses like mica, sulfur, coal, oxygen, gas, etc. They are all non-metal. Okay, then we identify metals on the basis of our daily experiences and information. There are many physical and chemical properties of metals on which they can be distinguished from other substances. Now comes properties of metals and non-metals. How do we identify that something is a metal? How can we be sure that a particular thing is a metal? So they have some characteristics, they have some qualities by which we can conclude that a particular object is a metal. What are those qualities? First is metals are lustrous. They have specific metallic luster. What is luster? Luster means shine. Okay? Luster means shine. Metals are shiny. Okay? Metals are shiny. Then metals are generally hard, but some metals like sodium and magnesium are so soft that they can be cut with a knife. Usually metals are hard, but exception to the sentence is sodium and magnesium. Exception is sodium and magnesium. Okay, question can come. What are the soft metals, or what are the exception of metals? Exception of hard metals. So you can write down sodium and magnesium. Then metals have another property called malleability. Called malleability. What is malleability? Malleability means that you can take a metal, okay, and you can beat it, okay, into to form a thin sheet. Okay, metals can be beaten into thin sheets. You might have seen a blacksmith beating an iron piece to make iron articles like a spade, a shovel, etc. What will happen if you beat a piece of wood? It will not, it will just break, right? But metals will bend, it will compress to form a sheet. Okay, then thin sheets are made by beating aluminium. Chocolate, toffee, and medicines can be kept safely in aluminium foil. If you've seen aluminium foil, okay, it is a sheet, right? Aluminium foil is a metallic sheet, okay, which is made by beating, or you can say giving shape to the aluminium metal so that it can become a sheet, okay, the aluminium that we use at home. The medicine wrappers also are made up of aluminium, okay. Then you might be familiar with the silver foil used for decorating sweets. The property of metals by which they can be beaten into thin sheet is known as malleability, okay. It is a characteristic property of metals. They can be beaten into thin sheets. Abraham, your video is paused for me. Okay. Now it's good. Okay. So we have metals are lustrous. Metals are generally hard, except sodium and magnesium. Then metals are malleable in nature, malleability. means they can be beaten into thin sheets. Then metals can be drawn into wires. This property is known as ductility. Okay, this property is known as ductility. Have you seen wires made up of copper and aluminium? Wires made up of copper and aluminium in the electric connections in our home, or the electric appliances in our home, such as microwave, oven. Okay, it can be in the fridge also. Okay, the washing machine, electrical like wires are there. Okay, so those are made up of metals such as copper and aluminium. How were those wires made? The metal is beaten, and then it is given the shape of that wire. Okay, so that thing where it can be made into wire is called ductility. Okay, then metals are good conductors of electricity. Metals are good conductors of electricity. Why? Because they allow to pass electricity through them easily. Okay, then metals get hot quickly because they are also good conductors of heat. Okay, they are good conductors of heat. That is why a lot of our cooking utensils are made up of metals. Okay, then metals are strong and solid. They are used for making buildings, trains, machines, bridges, vehicles, etc. Okay, a lot of metals are used to make a lot of big objects also, like vehicles, trains, and all. Okay, because they are strong and solid. Then there is another property of metals known as sonorous. Okay, known as sonorous. What is being sonorous? Means that they produce a sound when they are striked. Okay, when they are striked, or when they are tapped like this, they make a ringing sound. Okay, that is another quality of metals. Okay, the thing made of metals produce ringing sound when struck against a hard surface. Suppose you have two objects of similar appearance, one made of wood and the other of metal. Can you tell which object is made of metal by striking both the objects? Since metals produce ringing sound, they are said to be sonorous. Okay, ringing sound they produce. Then there is after considering the above properties, we can say that some metals are hard. Now, this is the properties summarized. Some metals are hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. The materials which generally possess these properties are called metals. Examples of metals are iron, copper, aluminium, calcium, and magnesium, etc. Okay? Then metals and so metals, like this is also important for a short question. Okay. Metals like sodium and potassium are so soft that it can be cut with a knife. And mercury is the only metal which is found in liquid state at room temperature. These two are exceptions. Okay. Sodium and potassium and mercury are exceptions to the characteristics of metals. Okay. Mercury is the only metal that exists in liquid
Ma'am,
form at room temperature. Yes, Abraham.
ma'am, what about Galatian?
Galasium. You are asking about the softness or the liquid state.
Liquid, ma'am.
Galasium does not exist in a liquid state, Abraham.
No, ma'am,
Okay. Your voice I cannot hear.
ma'am,
Gallium.
gallium does exist in a liquid state.
Gallium, you were saying. Abraham, it can be molten in liquid state. Okay. It is a soft element. Okay. And it can be melted into liquid state. Okay, it can be melted into liquid state. All metals, most of the metals can be melted into liquid state. Okay. Now, in contrast, materials like coal and sulfur are soft and dull in appearance. They break down into powdery mass on tapping with the hammer. They are not sonorous and are poor conductors of heat and electricity. So, what can be the properties of nonmetals? That they are soft. Okay, they are soft. Then they are dull in appearance. Means they are not lustrous like metals. They are not lustrous like metals. Also, they are not sonorous. Means they do not make a ringing sound, and they are poor conductors of heat and electricity. What the characteristics of metals are? The characteristics of non-metals are the opposite of them. Okay. Then the materials which possess these properties are known as non-metals. The examples of some non-metals can be sulfur, carbon, oxygen, phosphorus, etc. Okay. Any doubt in physical properties of metals and non-metals? These were the physical properties. Yes, Anna?
I understood everything, ma'am.
Ma'am,
Okay. Yes, Abraham.
ma'am, I sent you something in the chat.
Yes, you sent me. Liquid gallium is a soft silvery metal that melts at a low temperature. It is a liquid at temperatures above its melting point at a solid and a solid at lower temperatures. Gallium is used in various applications, including making alloys, semiconductors, and as a temperature reference point. Yes, Abraham, that's right. Okay. So when this liquid gallium, when this metal is at a low temperature, okay, above its melting point, it is a liquid, and below its melting point, it's a solid. That is true. Then we have chemical properties of metals and non-metals. Now, do you know that metals do have chemical properties? They react with air, water, and acids. Okay, the metals they react with air, water, and acids. Okay, now what is an example of this reaction? What is an example? Have you seen that metals reacting with oxygen and they form rusting of metals? Yes, rusting of metals is an example that metal reacts with air, reacts with oxygen, and forms a layer of rust. Okay, that is a chemical reaction.
Ma'am,
Yes.
uh, mercury is not the only liquid metal.
Say again.
Mercury is not the only liquid metal. There are lots of others.
Yes, Abraham, but mercury, it originally exists in a liquid state at a room temperature. Some of the other liquid metals, we have to like melt them, okay? Or only at a particular temperature, they would be in the liquid form, okay? Only at a particular temperature, they will be in the liquid form. But mercury, well, its like original form, its existential form is liquid.
Ma'am, I tell you that, ma'am, is because when you see any metal, ma'am, they're always in a solid, liquid, and gas. or any substance for that matter. But mercury's melting point, or up the point which it becomes liquid, is our room temperature or our temperatures. That's why it's a liquid. It's not because of anything else.
Yes, because its temperature at which it becomes a liquid is room temperature.
Ma'am,
That is not yes.
other ones like gallium, Pansanium, Sesamium, and Rubidium, they also have properties such as this that allow it to happen, allow them to get into liquid.
Yes, they can. Other metals, Abraham, can also be made into liquid form. Okay, once they reach that temperature, they can be into liquid form. That is right. Okay. Now, this is an activity. Collect a spoonful of rust and dissolve it in a very little amount of water. You will find that the rust remains suspended in water. Shake the suspension well. Test the solution with the red and blue litmus papers. What will you observe if it is acidic or basic? Similarly, when a copper vessel is exposed to moisture for a long time, it acquires a dull green coating. The green material is a mixture of copper hydroxide and copper carbonate, which is formed due to the reaction of copper with oxygen and water. Now, a copper vessel, it reacts with oxygen and water to form a green color layer, okay, that is called rust on its surface. Metals react with water. Sodium metal is very reactive. It reacts vigorously with oxygen and water. A lot of heat is generated in the reaction. Therefore, we store sodium metal in kerosene, okay, so that it cannot react with air, oxygen, or water. Okay, this is highly reactive. Then, generally, non-metals do not react with water, though they may be very reactive in air. Non-metals do not react with water, but they can be reactive in air. For example, phosphorus is a very reactive non-metal. It catches fire if it is exposed to air. To prevent the contact of phosphorus with air, it is stored in water. Yeah. Then, non-metals generally do not react with acids, but metals react with acids and produce hydrogen gas that burns with a pop sound. Okay. There are non-metals that do not react with acids, but metals, they react with acid and produce hydrogen gas, okay, that burns with a pop sound. Okay, we will stop here for today and we will continue from here tomorrow. Please try out in-text questions 7.1 for homework today. We will discuss this in class tomorrow. Okay. 5 minutes break for you all. 5 minutes break for you all. And then we will move on to maths.
Ma'am.
Okay, let's begin. All right. So, how are the tests coming? Can you all hear me?
Yes, ma'am.
Okay. So, please submit your papers by today. Maths papers. Okay. Anna Nathaniel, Emma science test, and Abraham science test. Please turn them in today. Okay. So, we were doing cubes. We were doing finding the cube roots by factorization method, and we finished it. We finished the lesson. Let's take a look at the next lesson. I think it's algebraic. Yes. Yes, Abraham. Asking something. Yes, we did lesson 3. Let's move on to lesson 4. That is introduction to algebra. Okay. In this lesson, that is the introduction to algebra, along with numbers, we use symbols. Okay. We use symbols, or we can say alphabets, like X, Y, Z. Okay. These symbols are known as variables. Okay. These symbols are known as variables in algebra. Okay. The use of these symbols helps us in writing results in short and general form. Okay. Also, algebraic techniques that are used in solving problems using information. We deal with one or two unknown numbers. Okay. These variables usually represent unknown values. Okay. Unknown values or unknown numbers. Okay. First thing that we are going to do is constant and variable. Write this down. Now, listen very carefully. In daily life situations, we have seen that the number of minutes in 1 hour is 60, number of days in a week is 7, and number of months in a year is 12. Okay. Number of minutes in 1 hour is 60. Okay. In 1 week, number of days is 7. Okay. In a year, number of months are 12. So, is there some hours where number of minutes will be 80, or some week where the number of days will be 8 or 9, or a year where number of months are 15 or 14? Heard anything like that? No, that is not happening. Why? Is because these values are fixed. Okay, these values are fixed. They are constant. Okay, they are constant. So the numbers or the values, yes, Abraham.
But the number of days in February change and the number of days in a year change. In February, it goes from 20, 28 to 29, and then 29 back to 28, and then in a
You
year,
were right about the number of days, Abraham.
65, 360.
Num- yes, you are right about the number of days. They change, leap year and all, they change. But I was telling about number of months, 12 months. Do we ever have 13 months in a year? No, we only have 12 months. Number of days can change, okay? Number of days can change, but the number of months remain the same. Okay, I'm trying to give an example of fixed values. I'm trying to give you an example of fixed values. Okay, fixed values. When we have fixed values or fixed numbers, these fixed numbers are known as constants. Okay, these fixed numbers are known as constants. But we don't know the number of days in February until we know the year. Okay. Also, um, suppose there is some item, okay, some item, a book that you are purchasing. At one shop it is 150 rupees, another shop it is 160 rupees, another shop it's only 135 rupees. Same book, but three different prices. So what is that now? That is there because the price is not constant, okay, but it is varying. It is varying. So that is why it is now when we don't know the fixed price, but it is varying, that values are known as variables. Okay, those values are known as variables. Um, you can write it down. Variables are represented by alphabets such as X, Y, or Z. Understood what are constants and variables?
Yes, ma'am.
Write this down, please. Take a look at this equation. X minus 3. Can anyone tell me, and this very basic equation, what is the variable and what is the constant? Which one is the variable and which one
X
is
is the variable and 3 is the constant.
Yes,
Ma'am?
Nathaniel.
Ma'am,
Yes.
ma'am, it's impossible to find out this. You need to know what is x equal to find it out.
Yes, Abraham, that's right. But this is an example only. Okay. This is not a complete equation, but a part of the equation to clarify.
Ma'am, this is an
What?
expression.
Yes, this is an expression. This is an expression to give you all an idea of what is a variable and what is a constant. Got it now? X is the variable because it is an alphabet, and 3 and the value of X can vary, whereas the value of 3 is fixed. 3 is there, 3 is 3. The value of 3 is 3. It is not going to change. That is constant. Okay, write this example down.
Ma'am,
Yes.
for every question, the variable is reset, right? Like, like the
See again.
like for every question, the value of the value of the variable is reset, right, ma'am?
Reset or set.
Reset. Like suppose in one question was a, see x is equal to 5. Then in another question, x is equal to 2.
Yeah. True, Abraham. For every question, the value of the variable can be different. Okay. The value of variable can be different. That's the thing about variables. You don't have a constant value. You don't have a fixed value. So yes, for every variable, the value can be different. Okay. Okay. Now, you know that in multiplication, shall I clear the screen now?
Yes, ma'am.
Okay. Now, in multiplication of constant and variables, in multiplication of constant and variables, when we are multiplying, suppose let's take a constant and a variable. What will be the answer to it? We write them together. Okay. Normally, we do not put multiplication symbol between a number and an alphabet or two alphabets. Okay. We don't put a multiplication symbol, but they are just written together. The product of 2 and n will be 2n. Okay. Understood?
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am,
Yes.
but sometimes we also use a dot notation. Like instead of writing x or a multiplication sign, is because it may be different. It may look like another x. We put a dot instead.
Yes, Abraham. We put a dot. 2 dot or dot here dot x means 2x. The dot in between also means multiplication. Okay. Then see, let me give you another example of a fraction. Okay, suppose you have a 12-meter long rod. Suppose you have a 12-meter long rod. Okay, and if we cut it into two equal parts, what will be the length of each part? If it is cut into two equal parts, what will be the length of each part? Six meter and 6 meter, right? 6 meter and 6 meter. Okay, which we obtained by dividing 12 by 2, which we obtained by dividing 12 by 2, or by doing 12 into half. That is how we obtain 6. But now suppose the length of the rod is n meter. The length of the rod is n meter. And we have to divide it into two equal parts. So what will be the length of the two equal parts? N into 1 by 2. N into 1 by 2. That is 1 by 2 n. So the two parts will be 1 by 2 n and 1 by 2 n. Understood the fraction portion of it? If we have to divide it in 4 parts, then 1 by 4n, 1 by 4n, 1 by 4n, and 1 by 4n. Okay, because the n, that is the whole thing, will be multiplied by 1/4 of the portion. Okay. Is it clear to you all?
Yes, ma'am.
Sure, all of you?
So, ma'am, if it's a variable
Hmm.
and you
Yes.
multiply it by the fraction,
Mm-hmm.
it would just be, so let's take for
Together.
example, yeah, it would be, yeah,
Say again, say Nathaniel, if we take an example.
so let's take an example of, 2 upon 4, and then we multiply it by y, which is a variable. The answer would be 2 upon 4 y, right?
Yes, Nathan. Yes. 2 upon 4 y. Okay,
Okay,
that is
ma'am.
right. Yes. Okay, so let's move on. Okay, Anna. Okay, so we will move on. Now, sometimes we also, I'm clearing the screen right now. Sometimes we also use the expressions, okay, that is a combination of variables and numbers to express a sentence, or a situation. For example, my sentence is Raman's age is double the age of his younger sister. Now tell me, do we know his
Ma'am,
age?
R is equal to 2s.
Yeah. So do we know his exact age, or do we know his sister's exact age? No, right? We don't know. So what we do when we don't know a value? we use alphabets. Okay, we use variables because the value is unknown. The exact value is unknown. So instead of using the exact value, we will use assuming value. That is variables. Okay, now who is the main person that we are talking about here? Raman's age. Okay, Raman's age. So we will assume that Raman's present age is X years, or we can assume that his sister's age is X years. Okay, Raman's sister's age. We have assumed it to be X years. Now the question says that his age is double the age of his younger sister. So Raman's age, double means into 2, will be X into 2. How much? 2X. Okay. How have we described Raman's age? 2X. Where did it come from? We assume that his sister's age was X. So to find out his age, we multiplied X by 2 because his age was double of his sister's age. So we can assume that his age is 2X years. This is how you express a situation or a statement in the form of an expression using constant and variable. Can you tell me in XM2 what is a constant and what is variable? What is constant and variable in these two?
Ma'am, the X is variable and 2 is constant.
Yes, that's right. X is my variable and 2 is my constant. Okay. Now, let's take another example. Can you express in expression form 1/4 length of a rod, 1/4 the length of a rod? What would be 1/4 the length of a rod? We just discussed this.
Ma'am, 4 upon
Yeah.
4 minus 1 upon 4 is equal to X.
We can assume that length.
So, ma'am, 4 upon 4 minus 4 upon 3 is equal to X.
We can assume length of rod to be X. The question is saying 1/4 the length of rod. So 1/4
Ma'am, X minus 3 upon 4.
length of rod would be
Ma'am, X minus 3 upon 4.
X multiplied by 1/4. Why? It's because I have to find out what will be the 1/4 the length of a rod. If X is the total, then what will be 1/4 of X? 1/4X. Okay. What will be the 1/4 of X? 1/4X. Okay. So it will be 1 upon 4 x. Look at this diagram. This is a rod. Okay, this is a rod, and I have to find out this total. This whole thing is x. This whole thing is x. Now, I just want to know what will be its 1/4 part. Okay, let's divide it into 4 parts. 1, 2, 3, and 4. Okay, I have divided it into 4 parts. I just want to know how much will be 1 part out of the 4. How much will be 1 part out of the 4? So what will I do? I will multiply, it will just be 1/4 part of the whole. That is my x rod. Okay. Abraham, are you getting 1 by 4x in the answer when you're doing x minus 3 by 4?
Ma'am, I think so, yeah, ma'am. So, because ma'am, when you do x, it's a whole number. It's like if you consider x as a whole, then you minus it by 3 by 4, meaning like you subtract 3 by 4 from it, then you're getting 1 upon 4. Same answer.
Same answer. Yes. So either you can just consider the one portion, 1 by 4x, or Abraham is doing this thing. He's taking these 3, okay, and then x minus 3 by 4. Okay. So that also, since we've considered x as 1, okay, or a whole, it will give us 1 by 4x. Okay. Understood how we have obtained 1 by 4x? Because it's the 1/4 portion. It's the 1/4 portion of x, which is the whole thing. Okay, Nathaniel, Anna, Emma.
Yes, ma'am, I understood.
Okay. Okay. Shall I clear the screen now?
Yes, ma'am.
Okay.
Ma'am, can we have another question to do?
Yes, you can have another question. 1 minute. This one might come a little tricky to you, but try it out and then we will do it together. Pair of a child is part half of the fair between two stations.
Ma'am,
Now try. Yes, Abraham.
by the fare of two stations, you mean the fare of an adult, right?
Yes. Yes.
Is the equation going to be f is equal to 1 upon 2x? Say c is equal to 1 upon 2x.
Answer is going to be 1 upon 2.
C is equal to 1 upon 2x.
C. What is C?
C is child
Child.
is
Child.
equal
Yes. Yes.
to 1 upon 2x.
Yes. Child is C. Correct. The C got me confused. Yeah. So this is station 1. Station 1. And this is station 2. Now, do you know that when children travel um, up to a certain age, they're up to 10 years or 12 years, they only have to pay half of the fare, of the ticket, rather the ticket. Only half the amount they have to pay. I think the age is 10 years something. And 2 years, it's free, like up to children that are up to 2 years, usually the train ticket is free. When there are children or some months, the train ticket is free. Then when they are up to 10 years, there is a half price that is charged. So here, when the question says that of the fare between two stations, means that the price that will be charged by for an adult, that is the full price, the child's fare will be half of it. So for that, you have to make an equation. The fare between two stations, suppose it's X. So the fare of child, it's given in the question, is half of the fare between two stations. So when the fare between two stations is X, the fare of the child is half of it. So 1 by 2 into X, which is, yes,
Could even write the equation 2c is equal to x.
2C.
2 children is equal to 1 adult or x.
Yes, Ibrahim. 2 children are equal to 1 adult or X, but right now there is no mention of 2 children, there is only mention of 1 child. So that is why half of X. Okay, understood the equation?
Ma'am,
Yes.
and then the other problem when it was talking about Raman's, you said two. You said Raman's sister's age is 2 times. Sorry, Raman's age is 2 times his sister's, and the answer was two. Like if his age was S and Raman's age was R, 2S is equal to R. Right, ma'am? So then why can't we not also say that if a fare of a child is half of the fare of a between two stations, we can also say that a fare of a child is 2 times the fare of an adult.
We can say that, Abraham. We can say that the fare of a child is 2 times the fare of an adult. It makes sense. Okay. Done? All of you are written?
Yes.
Then please note down the homework. Homework is exercise 4.1. You have some similar equations, some similar statements, of which you have to write the equation. Only three are there. Only three statements are there that you have to write down in equation form, expression form. Okay, so do that and send it in the group. Okay, finish the homework and send it in the group, the previous homework and this homework. Okay, test of chapter 3 is gonna be this Friday. Okay, test of chapter 3 is going to be this Friday.
Then what about chapter 2?
What about chapter?
2.
Okay, it's actually chapter 2. Chapter 2 test is there. So sorry, I got it confused. Chapter 2 test is there only, integers. The science is next Tuesday. Prepare for that. Okay. Tomorrow we will meet and continue further. See you all.